The fourth of our graphic series. This one here we're going to have a look at different forms of image transformation. So aspects like rotating an image or scaling it or fading it in and out. And generally we're interested about these things because we can use them to provide quite a wide range of different graphical effects. And again, that's going to help us within our game. Now we'll start off by defining and talking about some of the different types of transformation that we're going to explore here. They're all known as affine image transformations, or the majority of the ones we'll be looking at. And they give us a way of manipulating or transforming it. So if you look at the graphic over in the top right hand side, that's going to be our source image. Ways we can manipulate it, it includes, for example, resizing it. We could scale it up, we could scale it down, make it bigger or smaller in terms of how we're displaying it. We could also rotate it. We're rotating the image around some particular point. Isn't an image transform or a fine image transform per se, but we can fade the thing in and out. So whenever we're drawing it, now the image will come along with its own set of alpha values, but if we want, we can apply an additional set on top of that. So if we wanted to fade the object in or fade the object out, then we can draw it in that particular manner. The final one we'll have a look at is the notion of flipping the image, where the X or the Y axis is swapped around. There actually will be a specific use for that. We'll get onto it. It's really in terms of animation, which gives us an easy way of replicating or duplicating a set of animation data. So these are the basic forms. There's not too many of them. They're all reasonably straightforward, but they actually are quite powerful, and we'll take each of them in turn. So we'll start off with the idea of resizing images. And if you have a look at the screenshot that we have here and just spend a little bit of time to look at the graphics that are on it, you'll realize there's a good amount of repeated artwork. And we're drawing quite often exactly the same image at different scales, and doing that in a way to convey or to provide some sense of depth. So one of the uses of scaling an image is that we can, well, a couple of uses, we can repeat it, we get more use out of it, and we can use it as a way of conveying depth within a scene. So let's see how we can do resizing. Now the broad notion we're looking at here is we have a source image. You can see the source image is the grey rectangle drawn on the screen. And there will be a region of that image that we are going to copy and then to resize. Most often it is the whole image that we're going to resize. If we were thinking about an animation where we may have an image with several different frames within it, potentially we'll only take one of those frames and be interested in resizing that. So we're looking at the general form of taking a region of an image as our source, and the destination is how we want to display it at what particular size. So this is how we do resize it to make it a bigger size than the original or a smaller size than the original. Now, to do that in Android, let's have a look at a fragment of code. We have a few things that we're defining first of all, so we'll get those out of the way, then we'll show you the code that will enable us to resize. We're assuming in line 1 we have our image as a bitmap. For sake of argument, we're going to assume it's a 100 by 100 image here. That's important because if we're specifying the region within the image, we have to know how big the image is to make sure we're not taking more of it or trying to take more of it than is available. Line 2 and line 3 is our rectangles. The source rectangle is going to define the region that we're copying from. So this is the region within the bitmap that we want to take it from. Destination will define the area that we are drawing to. And if source and destination are exactly the same in terms of their width and their height, then there's no resizing. If the destination rectangle is twice as wide, twice as high, then we are resizing. We're doubling up in the size. Here's actually before we go into that, so line 4 we have a paint instance, we'll use this for drawing it out, and line 5 will have a matrix instance. A lot of the transforms we will use a matrix to build up the transformation to use it. Now for resizing it, there's actually two different approaches we can use, and both of them are shown here. So we've got our onDraw method, we've got a canvas that we're assuming we're drawing the bitmap to. And in lines, well, it's really 4 to 7 in terms of the code. This is the first implementation, and lines 10 to 12 is our second implementation. In both cases, we're going to be taking a part of our source image and doubling up on its size. So line 2, copy a 50 by 50 region from the center of our source and enlarge it to be drawn as a 100 by 100 region at position 2525 in the destination. So you can see in line 4 and line 5, this is where we set up our source and our destination rectangles. And effectively, that's where we do all the hard work in this implementation. So setting the source to be 2525, that'll be our top left-hand side, to 7575, that gives us a 50-50 region inside that bitmap. And likewise for the destination, we're starting off at 2525, 100 across, 100 down. So we have a 100 by 100 region within the destination. We're then making use of one of the methods that's available within the Canvas class, draw bitmap. Into that we pass the image we want to draw. We pass the source rectangle, that's what the image we're copying from, destination, where we're copying it to, and we're passing a paint instance because we can use that paint instance to draw it in different ways. Here, we're assuming it's just a new paint, so it doesn't do anything special with it, just draws the image out as it is. Line 9 down to 12 shows us a second implementation, and here we are using a matrix transformation to achieve exactly the same effect. So in line 10, we're setting our matrix instance for it to have a scale of 2 along the x and 2 along the y. So this says scale the x by 2 and scale the y by 2. And then we, in line 11, are adding on to that a translation, moving it 25 by 25. So this is one of the nice things about matrices. A matrix will let us transform an image. And into one matrix, we can add in several different transformations and they all get to be combined together. So in this case, we're scaling it first of all, and then we're translating it, moving out by 25, 25. And both of those two things added together accomplish what we want to achieve. Line 12, you can see then how we're drawing it. We take the image, we want to draw that out, but we're manipulating it, we're transforming it using the matrix, which will double the x and the y, and then move it 25 by 25, and that achieves what we want. And again, we pass in the paint instance, determining how we want to draw this. Ideal for depth of view effects, so we got this in the previous one. Object reuse, that we don't, graphics, images are expensive in terms of memory. If we can reuse the images, this is good. And we can also use it for special effects for resuming things in and out, as some examples of its use. Next one we want to have a look at is the whole notion of rotation. And again, if you look at this bitmap, you'll realize there's quite a few basic shapes, but we have rotated them and are displaying them at different positions on the screen. So rotation will enable us to do this. If we're thinking about rotation, the source, we will be rotating around a specified origin. What that suggests is that there isn't necessarily an origin, one origin, but we get to say the origin that we want to rotate about. Mostly we think about rotating the object about its center point. Although by default, if you just say rotate something, now it's not going to know where the center is, so by default it just assumes 0, 0, the top left hand side. So that will make a difference. So we have again a fragment of code here where we can have a look at how we can rotate images in Android. We will be using a matrix to do this. We've got our bitmap image, we've got our paint, just the default one, won't change it in any other way. And again, we're assuming our source bitmap is 100 by 100. If we wanted then to draw this out, you can see it here. We've got two examples. So in the first example, we're rotating it by 15 degrees around the 0, 0 points, the top left. And the second example, lines 9 to line 13, we're rotating it by 15 degrees about the center of the object. So you can see here how we differ in terms of specifying the rotational origin. So line 4, we have matrix.reset. Now this is important. So we declare a matrix in line 3, and we are resetting it in line 4. If we reset a matrix, basically what it means is clear it, blank it, put it back to the identity matrix, so it won't transform anything. And that's useful because if we were using that matrix to do some other manipulation earlier on, we want to make sure we reset it so we're starting from a blank, fresh point. You might say, why bother doing that? Why not just create a new matrix at that point? And you could, except that we're drawing things out. Generally, we'll be drawing lots of things. and we don't want to create a temporary object, a matrix object, for a very short period of time to create it, to populate it, and then to discard it. That's just going to lower or reduce our performance. So reusing it makes it more fast and efficient. Line 5 then is where we set the rotation, 15, or a value of 15. The important thing to recognize here, and again, depending on what sources you're reading online, so there's different aspects about rotation. One, mathematically, the amount of rotation, and if you consult most game programming texts, they are in terms of radians, whereas the value within Android is in terms of degrees. So 15 in this case means 15 degrees. So you have obviously 360 degrees in a full rotation, or 2 pi radians if you're measured in terms of radians itself. But Android uses degrees. So again, it makes it easier for us to think about it as programmers, but it is inconsistent in terms of most of the established norms about how we express an orientation, an angle, a rotation. 15 as well, you might think, okay, if we're rotating 15, is that to the left, is that to the right? Which way is positive rotation? By default, clockwise is considered to be a positive rotation, anti-clockwise considered to be a negative rotation. So line 5 sets the matrix up to rotate it by 15 degrees. Line 6 says that, okay, let's rotate the image and then let's pull the thing out to 50-50, and we'll draw it at that particular location. And then we draw out that image using that matrix and with the default paint. And line 9, we're going to do exactly the same thing, except we're not rotating about 0, 0. We're going to rotate about the center of the bitmap. So remember, it's a 100 by 100 bitmap. So line 10, we reset the matrix. So this removes the previous rotation and translation. It puts it back to the identity, the starting matrix. We're calling in line 11 the set rotation method, but we're calling a different version of it. So it's still 15 degrees, but now the next two parameters tell you whereabouts you are doing that rotation. And 50-50 corresponds to the middle point of a 100 by 100 image. Line 12, we're moving it exactly the same, 50-50 down the screen, so the translation is exactly the same, and we draw it out in the same way on line 13. So yeah, quite straightforward. Fading is the next one. So again, a screenshot here, you can see sometimes within a game you may want to show items as faded in, faded out to some graphical end or purpose. How do we do this? We're going to be controlling the alpha value in this case to specify exactly how the image will be drawn out with what blend function. We've got an example of the code here. So bitmap image in line 1. It doesn't really matter about the size of it. Again, we're just assuming it's the same type of thing we're loading in. And we actually are going to make use of our paint instance in this case. We'll create it, but it's not just going to be the default one we use when we draw it. So here we have an example of how we can draw an image out with 50% alpha fade. So it's 50% out, 50% there. Now, important to remember here, all images, well, not all images, but most images we load in may have defined alpha values, maybe transparent, maybe translucent. So this is an additional one that we apply on top of whatever the default alpha values that the image has itself. So how do we draw it out? So you can see this in line 4. We're going to the paint. The paint has a set alpha method. You can pass in a value of 0, means it's completely turned off, to 255, so it's completely visible in whatever the base image provides. So by setting the alpha to be 128, effectively it's 50% fade. We then draw out the image, in this case position 100 and 100 with that particular paint. And in line 5, you could replace it with any of the previous ones. We could be transforming it with our matrix. We could be doing a lot of other stuff. Doesn't really matter. Whatever we draw out now using that paint instance will be drawn with 50% fade. Line 6 is important because there, when we finish drawing it out with a certain alpha value, we reset our alpha value. We put it back to the normal, just show whatever the image wants to be shown. And if we forgot to do that, it means then we will always keep drawing things out as long as we're using that paint instance with 50% alpha. Ideal for appearance and disappearance effects, for making things appear and gradually go into a game, or if something's been picked up, you could just make it disappear in a poof, but quite often it's better to let it gradually feel out. It looks a more professional approach. Flipping is the last one we want to have and explore of. So the types of things we're talking about here is the source rectangle will be flipped relative to its destination. So you can see an example, we can either do it on the X or the Y axes. Looking at the X axis example, so the top is still the top, the bottom still the bottom, but what was the right becomes the left and what was the left becomes the right. So that's how it gets swapped around. Or you could do it also with the top and the bottom changing over, but the left and right remain the same. Why do you want to do it? You can see an example of the graphics down in the very bottom. So this is an animation of a character walking to the right. And in a game, they might be able to walk to the right, they might be able to walk to the left. So as opposed to having two sets of graphics showing animations right facing and left facing, which is quite wasteful of memory, it would be much easier to use one set of graphics. And when we're drawing it out, because we're going the other way, rotate it around. So that's quite often where we'll use flipping, is to, depending on the direction, the orientation that we're showing the image at. How do we do this? So here we need to know the size of our image. This actually will be important, the overall size of the image, so 100 by 100. We got our source and our destination rectangles, and we got our default paint. So we're going to show two examples here. The first one, lines 4 to 7, are just drawing it out normally, so it will look as it should look. And on lines 10 to 13, we're going to draw it out, same size, same location on the screen, but flipped along the Y axis. That'll be the only difference between the two. So you can see in line 4, we're setting up the source to be 25, 25 in, 50 and 50 down. Destination, so we're going to position 450 as the top left to be 450 and 100 down, so that's a 50 by 50 region for the destination rectangle. And we're then drawing that out. So that will take the middle 50 by 50 of the source, draw it to that particular destination. So much so good. That's our starting point. If we wanted to do exactly the same thing as that, but draw the image flipped along the Y-axis, you can see the differences we need to make down in lines, well, it's really in line 10. So line 11 for the destination and line 12 for drawing it out, line 12 and 13, no change whatsoever. Looking at the source, it may take a little bit of time to think, oh, hold on, what's going on here? That's the important bit. So now we are saying the top left-hand corner is 75, 25. And the bottom right is 25, 75. So if you think about it there, we have flipped the two things around. And that is where the flip will have occurred within it. So if we're drawing it out at that point, we swap them around within our destination rectangle, and we then draw them out to our target, or swap them in the source, draw them out to the target destination rectangle. Okay, so that's basic forms. More interesting things happen whenever we just don't do one of those, but we start combining them together, and we can get lots of quite powerful, interesting aspects emerging from this. There's something to be cautious about here, in that if you think of, for example, multiplication or addition or things like that, so 3 times 7 is the same as 7 times 3. You can swap them around. That isn't necessarily the same for matrices. That if you have two matrices, and you can multiply matrices, that matrix A multiplied by matrix B, which basically says do transform A and then add on that transform B, is not necessarily the same as do transform B, then do transform A. Show you an example here, hopefully make it a little bit clearer. So let's assume that we have XY axes. We have a starting point at 2, 2, is the red circle, and we want to do two operations on it. So the first operation, A, is translate by 2, 2. So we're going to move it 2 along and 2 up. And the second operation, B, is rotate 90 degrees clockwise. So if we're doing the first one, you can see that 2, 2 gets turned into 4, 4. And we then rotate it, so there we can, rotating it along a circle, so rotating about the origin, 90 degrees clockwise will bring us down to the point 4, minus 4. So far so good. But if we looked at it the other way around, so we're rotating 90 degrees first of all, and then we are translating by 2, 2. So this is the equivalent to, from AB to BA. So in that sense, we rotate 90 degrees. So our 2, 2 point, again on a circle, goes to point 2 minus 2. And if we translate, that brings us up to the 0.40. So you can see in this simple example that the order in which you combine the transformations will most likely have a different, determine what the output is, will change it potentially. Now, it doesn't actually present as big a challenge as you might think. There is actually a rule of thumb that you can use to do this safely, and it's known as the ISROT combination. So matrices can be safely combined using the following sequence, ISROT. Start with the identity matrix. So identity matrix is one that doesn't transform anything. So otherwise stated, just start with a new matrix or a reset matrix. Creating both of them in Android default will give you an identity matrix. First operation you should do is to scale it. So if you want to scale it, make it bigger or smaller, do that first. After that, rotate about the object's center. Now, specifically, this is about rotation around the object's center. You'll see there's another orbit underneath it, which is a separate rotation. But if we want to have an object that's rotated about its center, we should do that next after we've scaled it. And to be honest, you could rotate and scale, doesn't really matter which order you do those particular two. Orbit is a rotation about some other point. So for example, around an origin or some other reference point. So we might have, again, I mean, this could be a part of an image, part of a larger model that is able to move, and the parent that it belongs to itself is able to move and rotate around. So if we do want to orbit about some other external point, basically it's a rotation about some other point, we do that after it. Finally, what we do at the very end is to translate it. So we move it to wherever it lives in the world. So that's the last thing that we do. And it's important to do it last because if you are moving it, that's going to have an effect on any of the rotations we do thereafter. So you see example of the code on the right hand side. Reset your matrix is one way of getting it to identity matrix. Do the scaling. Do a rotation about the center. Do, if you want, an orbit. And quite often you don't need to do an orbit around some other point. And then finally translate at the end. By combining these effects together, you genuinely can get quite a lot of very interesting graphical effects. And actually in the lecture, we'll spend a bit of time getting you to think about how you can combine these in quite interesting forms. So here actually is an example. It's an example of a particle system. It's a fairly sort of nice looking explosion. But if you look at that explosion, it looks impressive. The totality of that explosion is made up of the 6 small images that you see up in the top left-hand side. So all of those is simply repeated drawings of those images, except when we're drawing them out, sometimes we're scaling them, we're translating them, we're fading them in and we're out, we're doing those types of things. And by manipulating those, we can get quite sophisticated graphical effects. And you might want to spend a little bit of time now just having a ponder how you could replicate that type of image. And best thing is to look, if you look at it carefully, you'll realize that actually, yeah, this is just small images that have been redrawn on top of them each other. So the challenge comes to how do you do this and how do you coordinate it, but it is a very powerful technique. Key takeaways then are only a couple. So image rotation, scaling, fading and translation offer a very capable means of controlling how images get to be drawn, that's true. And you should be thinking about, well, how can I make use of these within my own game? Most games it'll be applicable in some way or some aspect. It will help by way of making the game visually more impressive. It can help by way of giving you the opportunity to get some more sophisticated algorithms into your game. Now that's all we want to have a look in this particular one. The next one, we're going to go on to have a look at animation and how we can animate a sequence of images to bring them notionally to life.